Hey everybody, Joe here with Speedway Motors, and we are here with Lake Speed Jr. from Total Seal Performance, and we're going to talk about piston rings. And maybe the first and most obvious question that people have is, how do you install them and how do you clock them?
Well, the great thing is they actually come with an instruction sheet that actually shows you how to do it, but we know, car guys sometimes don't like to read instructions, so that's why you're watching the video, right? So the most important thing to understand with a piston ring is that there's three different rings. So you've got a top ring, a second ring, and the oil ring, and they work as a team to create the ring seal. Because, you can have fuel, air, spark. That's gonna make combustion, but it's not gonna make any power to move the piston if there's no ring seal. So what we do is this team is working together to do a couple things. One, it's gotta keep the combustion sealed up, but you also don't want oil from the crankcase getting up into the combustion chamber because oil has a lower octane value than your fuel, so it can cause detonation and things like that, all bad things. You don't want it to smoke anyway, right? So the idea is you need to have a gap on the end of the ring to allow you to install it and also to allow for thermal expansion. But what you don't want is all those gaps lined up. So that if these gaps are lined up, well then you basically have a straight shot. And then oil can go this way, combustion can go that way, and that's not a good day. Now, what we do is when you install them on the piston, you want to do is begin with the oil ring. So you're going to put the scraper rail on first, and it goes on the very bottom position. Then you add the expander, which is really the spring that pushes those rails out. So they're doing the gross oil control. They're scraping off the oil, but you have to leave some oil because oil is the gasket between the piston ring and the cylinder wall. So without that oil, there is no gasket, there is no seal. So you want to make sure you can keep that. So that expander goes in, then that top rail goes on, that completes the oil ring. You always want to make sure that those gaps are offset 180 degrees from each other. So what we like to do is go on the anti-thrust side and put in the bottom rail. So that gap's on the anti-thrust side. Then you flip it over to the thrust side and then you put the other gap. Now, when you put in the second ring, you're gonna put that second ring 90 degrees away from those on the exhaust side. Then you're gonna put the top ring 180 degrees from the second ring, and you're gonna put it on the intake side. Because the intake side is a little bit cooler because that's where fuel's coming in. So again, that end gap is for expansion. Because if those ends touch each other, it's a bad, bad day. So you wanna make sure you have enough end gap. Of course, that's a whole video by itself, but end gap is also listed in the instruction sheets on how much to do. A normal rule of thumb for a forged piston that's say either 4032 or 2618 aluminum piston, you're gonna normally run, say for a street application, about 5 thousandths per inch of bore size. So just say for a 4-inch bore like this piston is, that's gonna be about 20 thousandths end gap between that top ring and second ring. And then you want a minimum of 15 thousandths total end gap on your oil rails. So that whole package will put most people with a typical street application in there. As you go up in power, if you add boost, you add nitrous, then you have to add gap because the hotter it gets, the more those rings are going to expand, the closer they're going to come together. And again, you don't want them to touch, but you also don't want them to be massively loose, although people tend to overthink that, right? We typically see people get too worried about trying to get, if I have 20 thousandths end gap or 25 thousandths end gap, I'm gonna have too much blow-by. Now the reality is we have engines that have 30 thousandths end gap and they have almost no blow-by. So as you try to set that gap, just think about the power level, the compression, what kind of fuel you're running. If you're running methanol E85, it tends to run a little bit cooler. You don't need as much gap, but typically if you're doing that, you're running more compression. So you're gonna have to add that gap back.
Right. This orientation that you're describing, this is across the board, Chevy, Ford, you name it.
Doesn't matter.
And it doesn't matter, forged piston, hypereutectic, same deal.
Same deal. Single cylinder, 4-cylinder, 6-cylinder, 8-cylinder, V16, it doesn't matter. You want to maintain that same clocking order. That way you don't allow them to have that straight shot. You want to make sure that they can work together because that top ring, it's doing compression. That's all it does is seal compression. The second ring is doing partial compression, about maybe 25% compression, but 75% is that fine oil control, where those oil rings are doing that gross oil control. They're really scraping the oil off, and it's feeding it back through the drain back holes. That way you're taking that oil on the cylinder wall, pushing it back through the drain back holes. But that second ring is leading that fine coat of oil to be the gasket and the lubricant for the top ring. Without any oil, there's no seal and there's poor lubrication, so it won't last as long. So that's what's really cool about, piston rings is it's a team. They're working together. It's not just one ring, it's all three and how they work together. And the clocking of them and the gaps are really important to make that team play well.
Once you have them installed, the engine's running, do they rotate?
They actually do. Yeah, so they're moving all around. That's just what happens. Crosshatch angle can have an impact on that. The speed of the engine, things like that can impact it, which is, it's okay that if you take it apart and they're moved around, it's okay, it's not a problem. But you want to have them begin with those offsets, so as they move, hopefully they maintain that offset so they don't line up. Because when they line up, you're gonna have a high blow-by.
I mean, there's lots more information to go here, lots more on the toolbox at speedwaymotors.com. Lake, thank you. Thanks everybody for watching.